everyone. I'm Nicole Harris.
And I'm Tessier.
And this is our podcast,
Between Two Fans. Okay, so today's episode is about electrification, and today's guest is Cody. Would you like to introduce yourself?
Yeah, absolutely. Well, my name's Cody Albertus. I've been working at Horton for about 7 years now. I started as a product manager and moved into roles in sales and aftermarket, and now I'm leading the electrification effort here. So been doing that. Before that, I worked for Cummins, so I've been around diesel engines for almost 20 years of my life now. So it's been a lot of fun.
Okay, very versed in the heavy-duty engines.
So what's your current role at Horton now then?
Yeah, Senior Business Director of Electrification.
Okay, cool.
Yeah. You know, maybe to go into it a little bit, so the role really is important because we're investing a significant amount of money into this electrification realm.
Right.
And we want to make sure that we're spending it right, our resources are working on the right thing, so that when the industry really starts to move and take off, we have the right products for that business.
Okay. How long has Horton been in electrification? And did it start like when you moved into that role, kind of? Or was it started a little bit before that?
Yeah, it's actually started quite a bit before that. When I was as the account manager for PACCAR, that's when customers really started asking for products that would support their BEV vehicles, battery electric vehicles, or zero emission vehicles, so like fuel cells and things like that. So that was probably like 2020, I'd say. Okay. And we started working with these customers, and now we're very close to having products go into production. I'd say end of this year, we will have products in production, going on trucks, going around in the world. That being said, it's not just about trucks. It's about off-road vehicles as well too. Emissions regulations are driving the change.
Mm-hmm.
Okay.
Could you kind of briefly detail some of the designs that go into electrification versus our core products, and maybe like some of the voltage that you guys use?
Yeah, absolutely. There's a lot there.
Yeah.
You're not letting me off the hook at all here. All right, so one thing that I think is really important to talk about is like a lot of people think about battery electric vehicles and they're like, why do you even need to cool them, you know?
Right. Mm-hmm. Yep.
You know, like we have these huge radiators and fans, and that's really our business, and clutches, turning fans off. Like, why do you need to do that with a battery electric vehicle? You know, we don't have, why is there need for this radiator? So when you think about a diesel engine's, I'm going to talk in just really high level generics, right? 50% efficiency is what a diesel engine is at converting fuel into energy that you want to use. Mm-hmm. So the 50% that's inefficient, so that turns into heat and noise and all these things that you don't want with the vehicle. And really our fan in the traditional rice engines is cooling that 50%, getting rid of that heat. With the diesel engine, though, you have an added bonus is that you have an exhaust pipe.
Right.
You're sending a ton of heat out that exhaust pipe so that you don't have to cool it in the radiator. Mm-hmm. Well, with a battery electric vehicle or a fuel cell vehicle, there's no exhaust pipe.
Yep.
So you can't just get rid of the heat. You have to deal with all of the heat that's generated.
Oh, okay.
That makes sense.
So it's, you know, it makes it a little bit more complicated. So when you look at a electric vehicle, it is more efficient. So you're probably talking like 85% efficient, something like that. So you have 15% of heat, but it's still in the same ballpark in the end of what is needed from the cooling system. It's a little bit smaller with the battery electric, but with fuel cells, it gets a lot worse because a fuel cell is actually about 50% like a diesel engine. So you're still, and then you have to deal with all 50% in your radiators.
Okay.
So if you see a fuel cell vehicle, you'll see all these radiators stuck all over the place.
Yep.
Yeah.
And that's why, is because the engineers are like, I have this form factor that I got to build this machine.
Yep.
And there's just not enough spot for radiators, so they're like hanging them everywhere. So that's a big challenge for our customers is dealing with those kind of changes.
Do the electric ones, do they require the same cooling as the diesel would? Or do they create less, where we have to have less cooling? If that makes sense.
Diesel to battery?
Yeah.
It's roughly the same.
Really?
Yeah.
Okay.
Yeah. I mean, it's a little bit less, I would say, but it's really hard to say. Like, a lot of companies out there, I think, and our strategy is too, is that right now you don't really know what the end game is going to be. All we know
Right.
is by 2050, pretty much all the vehicles that we use and see that have a reciprocating engine in are going to be battery electric or fuel cell or something that we haven't even solved yet,
Yep.
right? So we got to get from right now to there. I mean, there is so many problems
Right. Yeah.
for people to solve, right? And we got to solve them. And so I always think about it like, as an engineer, I love being an engineer in this time of our history because engineers love solving problems.
Right.
And this is going to be like the biggest problem in our lifetime that we're going
That
to
we're
solve.
gonna have to solve.
Yeah.
Is how to get from here to here. And I was listening to a speech from a guy from Dana, actually, and he talked about he's like, everybody's really concerned over this big thing, like, oh, how are we going to do this? It's going to cost so much money. And he's like, peel it back, guys. Go back 100 years. Go back to 1905. Everybody was riding horses.
Yeah.
100%. Yeah.
There was no roads. There was no gas stations.
Yeah.
We have to solve that exact problem that they solved in the early 1900s now.
Yeah.
Yeah.
So we'll get there.
We'll
kind
get
of-
there.
It's better
Crazy
when
to
you,
think about.
when you look
Yeah.
back, because we've come so far in such a short amount of time. We can do the same with electric vehicles.
we can do it. We can do it. It's definitely an achievable thing for us to do.
So
Okay.
with that, have there been any successes and challenges since this is a new problem for everybody? Have you
Oh.
found a bunch of successes and challenges?
Absolutely. Every day. I mean, yesterday's success is today's problem sometimes. I mean, it's really insane. One big problem for us is it takes a huge investment to make these new products
Yeah.
and become a new company almost. Not a new company. I mean, it's still going to be Horton, but we have to solve the problem differently about cooling vehicles and the timing. We worry about creating an e-motor and a fan, like an e-fan assembly, and how hard that is for us. I mean, can you imagine the vehicle manufacturers, what they have to do that to a
Yeah.
whole vehicle? I mean,
Yeah.
It's a whole vehicle, not just a component.
Yeah.
I mean, you're talking hundreds of millions of dollars just to change probably one platform for a
Yeah.
company.
Yeah.
And it's so that's a big problem. And timing, all those problems, turns out if you don't solve them all in the right time, your schedule starts slipping. And
Yep.
that's always a day-to-day problem for us. Is it's a benefit because we're like, oh, now we have time to get this done and do this testing
Yep.
and get things done faster. But then also it's a problem from a financial standpoint. You've invested all this money over here, and the further you get away from start of production and being in production, that money,
It's just stuck.
It's just stuck. You're just losing money. I mean, if you would invest it in a bank, into a savings account these days,
Yeah.
you'd be doing a lot better.
Yeah.
Right.
So, that's a constant problem that's going on with this industry right now. Is where does the money come from? When do you invest the money? So, that's hard. From a technical standpoint, working with one of the customers, the form factor of their vehicle, I think it was some of their senior management came down, they looked at the truck, and they were like, this truck doesn't look like a Tesla or some,
Yeah. Yeah.
of a battery electric vehicle. We want you to make it really cool with lightning bolts on it or whatever, right?
Yeah.
So they came down and they said, we want the front end to look like this. Well, that's where the fan is,
Right.
So it's we have to.
You have
we
to design it around the fan.
Yeah.
Yeah.
And so we have to find a way to put our products in there.
Yeah.
And which is what Horton's awesome at, because I mean, you guys know the application engineers that we have at Horton working on all these small problems. That's where we succeed, because where others don't want to get into those details, we
Yeah.
want to get into those details, and that's where we enjoy to be. So
Right.
Yeah.
It's fun also. It's a lot of fun to solve all these problems.
Could you tell us just a little bit on how electrification is changing the truck market, kind of in terms of like how like it's going to work for companies, like different like monetary aspects to it?
Maybe like what
Different
percentage
labor.
of the truck market is maybe changing over to electrification in the next few years, if you know that?
And how it will affect.
Well, do you
like,
guys know that?
transportation.
I don't.
No, I don't know that. I don't.
I mean, if we could just bet on it, it would be fun.
Yeah.
I mean, that is really the number one. It's a tough question. I read an article this morning. There was a reflection on this topic. The federal government on Monday passed a new law for emission standards
Okay.
for the U.S. They're targeting 30% zero emissions vehicles by 2032.
Okay.
Okay.
We're roughly like right now, probably for medium duty, heavy duty vehicles, like 1%, right?
Yeah.
Something like that. So we got to
Very
go
low.
1% to 32% by 2032, which is a long time, but it's a really short amount of time too.
When you have
Yeah.
to design all these new things.
Yeah, and a lot of companies, and then when you go and you talk to the companies and listen to what the big players in the markets are saying, Deutz, Deere, Volkswagen, Daimler, PACCAR, what they're all saying is roughly pretty similar. Actually, is in that 2030 range. They're targeting 20 to 30%, something
Okay.
like that.
Okay.
And it's pretty much widely understood that by 2050, we need to be pretty much not using reciprocating engines by then.
Okay.
Okay.
That being said, it's going to take a long time. I always preface that with something that's true about our business that is very surprising. A big part of our business is aftermarket truck business, right? We sell a lot of clutches on trucks. And it turns out they're really old trucks. We have a clutch called the HTS. That clutch, when you look at our aftermarket sales, 2 of our top 5 part numbers are HTS clutches.
Really?
We haven't put those on a new truck in 20 years.
Wow.
Legacy clutch.
Yeah.
Yeah, so I mean, people keep their vehicles and their investment for a long time
Yep.
in this industry. And that goes for off-road and on-road or truck. People do hang on to their vehicles, and they need to service those vehicles for a long time. So, to think even if today everything went to 100% electrical or zero emissions, like
Yep.
you're probably still talking about 50 to 100 years before you don't need to support or have
Right.
people available to support that market.
Okay.
Okay.
So it's a long time. It's going to take a long time to make this change, but it's starting to happen.
Interesting.
So when it comes to like existing trucks, does Horton work with the companies to like kind of integrate the electrical solution into existing trucks, like kind of retrofitting them?
We could decide to go after that market in the future, but right now we're not really looking at it. The reason is usually when you're talking about retrofits onto existing vehicles, if you don't have a product that integrates super well or really easily, it makes it really hard. And if you think about, let's just talk about like a diesel wheel loader or something, you want to put an electric cooling system on there. The one that we're designing right now is high voltage.
Yep.
And so what that means is that it runs off of the voltage that the batteries put out, which with a diesel engine, usually you're talking about 24 volts DC, 48 volts DC, something like that. Whereas high voltage, you're talking 650 volts DC or 700 volts
So
DC.
way more.
Yeah, so way more. And the reason why you do that, there's really good reasons. That's pretty interesting if we want to get into the techie side of it a little bit. But when you talk about power is for electricity, it's P equals VI, right? So voltage and current is proportional, right?
Yep.
So as voltage goes up at the same power, current's going to drop
Right.
down, right? So when you talk about that voltage for, something that takes like 100 amps, you have to size your cabling around the amperage, right?
Right. Yep.
So at 24 volts, your amperage is going to be really high to get 10 kilowatts of power. At 10 kilowatts of power at a voltage of 700 volts DC, your amperage is going to be really low, so your cable can be really small.
Right. That was actually a question I remember in my classes in college.
Way to go. You remember something from college?
That's about the only thing I remember about, like, electric stuff.
I remember a whole bunch of stuff about college that we can't talk about today.
Yeah.
I was surprised I remember as much as I do from my electrical class because it was all online.
Yeah. I remember that one was, like, a sneaky one that got me on quizzes, though.
Yeah.
Oh, yeah.
Because I do remember it was, like, if you have a larger whatever, like, power or whatever, can the cable be bigger or smaller? And I remember I got that one wrong, so I learned from my mistake.
Yeah, but it leads into the design of their machines. The higher the voltage you can go, the smaller the cables.
Yeah.
And when you look at these vehicles, there's it's a rat's nest of cables under there.
Oh,
Yeah.
I'm sure.
And so if they're bigger, it's heavier. They are harder to bend, because wires have bend radiuses, minimum bend radiuses that you have to deal with. The other part too is when you're if we were going to make a low voltage fan for 10 kilowatts and the batteries are at 800 volts, you have to convert the DC voltage down to 24, 48 volts DC. So you need a DC to DC converter. Those are expensive. They have efficiency losses. And on future vehicles, efficiency is really going to be king when you're talking about it, because that's like an extra 10 miles that somebody can drive,
Right.
or an extra 30 minutes that they can do work.
Less charging time.
Less charging time, more time that the company can use the investment in the capital investment of the equipment
Yeah.
Yep.
for what they get paid for.
That's really important for a lot of industries.
Oh, it's absolutely, it's huge. I mean, if you can optimize the users, total cost of ownership and profitability, that's how you sell your equipment, and that's what Horton does. So, I'm really bullish about this change because I think it fits right into who Horton is.
Yep.
It's going to be all kinds of crazy problems. You're going to have to get your hands dirty to solve them, right?
Yep.
And that's what we do, and that radiates from the manufacturing floor all the way to Cordell in the president's office.
Yep.
It's just who Horton is. So
Always innovating.
Absolutely.
So we talked a little bit about on highway. Could you give us a little bit more details about off highway electrification?
Yeah, absolutely. So with off highway, it's probably 5 to 10 years behind truck, roughly.
Okay.
It's a much harder application to electrify because, at least with a truck you can be driving on a road. You know it's going to be on a road. It's going here and there. But
Yeah.
like construction, there'll be construction site here this year, and then next year it'll be across town or it'll be a different place. So you have a moving target, which makes it a little bit more challenging, makes for different solutions, more different problems.
I feel like you also have to protect some of the components a little differently depending on the environment that the application's in.
Oh yeah, for sure. The environment is a big part of construction. You got rocks and you got dirt.
Way
and
more dirt flying all over.
all kinds of things.
Construction debris, I'm sure.
Yep. So you have to design for those things in mind. The other part that's with off-road, in general with trucking, you have a 9-liter diesel engine to a 15-liter diesel engine, something like that. With construction, you got
All
and
sorts.
mining and all that, so you got a half horsepower all the way to a 3,000 horsepower engine that you have to deal with. That's on the ultra class mining trucks, all the way down to lawnmowers, right?
Yeah.
Small lawnmowers. So it's a much more diverse application.
Yep.
And so we need a much more broader product portfolio as well to support
Right.
it.
Yeah.
So we got a lot more unique situations we got to fit into.
Absolutely. And you can also see that from 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 one of our customers, they also use that diversity of engines as well. So where trucking needs to invest money in a couple of engine platforms, they need to invest in solutions across a wide range. So their investment is a lot
be way bigger.
Yeah.
So we talked about the difference between the markets on highway and off highway. What about the differences between U.S. and European markets for electrification?
Yeah, absolutely. One thing is you start thinking about the two markets. The U.S. can be seen as a little bit easier of time to integrate electrification. You wouldn't necessarily think that right off the top of your head, because in general in Europe they drive these kind of changes a lot faster.
Yeah.
But they also really preserve their history a lot. So there's a lot more codes around like where you can put new power lines and things like that. And with electrification, you need to now charge everything, right? So this infrastructure.
Right. So you'd have to have a different infrastructure.
And a lot of these towns have been around for thousands of years, and they're like, oh, we just need to, drill a big hole right in the middle of your city. And they're like, no,
we're not
no,
doing
thank
that.
you, right? So there's a lot of problems like that have to be solved in Europe that can be a lot more challenging.
Okay.
That being said, in the U.S., it's a lot bigger of space, So now you're like, so it takes time. The emissions regulations that are driving it between the U.S. and Europe are pretty similar in timing.
Okay.
They kind of are driving things. So that's from a legislation and maybe from an infrastructure standpoint, there's a little bit of differences. The solutions aren't terribly different. When you think about how that impacts us, we still need to have an electric motor that runs a fan. We're going to need different fans probably for different power sizes and airflow requirements. But the infrastructure really is a big difference between Europe and North America that'll change things. There was something that was kind of interesting that I read about this week. It's called the Green Lane Initiative, I believe it's called.
Okay.
It's an investment between Los Angeles and Las Vegas, and it's a multi-billion-dollar investment.
Oh.
And every 70 miles or 60 or 70 miles, they're putting a charging station for medium duty and heavy duty truck. And so it's starting to happen.
Yep.
And you're going to start seeing that happen a little bit more and more. I also like when you think about mining tends to be interested in taking on kind of technology like this too first. So you could see where that you might see the mining industry start taking it on.
Okay.
They use a lot of electric motors and stuff in their big vehicles already, but then they have like a generator set on the vehicles, and then they use that to run the actual motors and stuff. So the application is there. Another part that happens with mining is they usually have a lot of land in the area, so they put up solar farms or wind fields to put in green energy as well. So, there's maybe not as much of a infrastructure cost for them.
I'm going to ask you a question. I'm sure you've gotten the question a bunch of times. How does it make sense to have an electric motor but then have a generator behind it that's not electric? Aren't you still putting out into the world the same emissions? Maybe not the same, but you're still creating emissions.
Yes,
right?
Absolutely. Especially now, so if you think about it all the way back to the power company, right? You're generating power at the power company, and you're putting transmission lines out, all that infrastructure out, driving it charges a battery, and then you're using it, right? So there's a lot of losses in that situation. And right now, most of that power, no matter where you are, it's coming from carbon-based fuels.
Okay.
Coal, natural gas. So when you when you look at it, you're like, maybe it doesn't make that much sense, right? Because you're still needing to burn these things. There is, at a power plant, they do a really good job of like burning everything and doing it really efficiently. So like, if you think about like a diesel engine, 50% efficient, a power plant is probably 95% efficient, right?
Yep.
At using that same fuel. So,
Okay.
so there is a benefit there from just that. The other part is that when you look at, that's now. If you look down the road, right, you start looking 2050 or 2060 when we start investing more into different types of infrastructure. There's more solar fields out there. There's more windmills. There's tidal energy. There's more nuclear power. There's all of these zero carbon fuels and energy available on our grid. You have to enable that usage by having battery electric vehicles or zero emission vehicles in operation.
Okay.
So you can never get there without making the investment in the vehicles first before you drive the need. So,
Okay, that makes sense. So we're just on our way to less emissions. It's never going to be like completely not there.
Correct.
Okay.
It'll be an ongoing battle for our whole lives.
Yeah.
I would say. I always talk about, like, I remember when I was a kid, it was like, I forget what the numbers are, so don't ever, I hope there's not people out there that are like going to make all these comments on this thing about, but I think it was like something like 5 to 10 bald eagle nests in Minnesota, back when I was a kid. And now there's bald eagles everywhere. You see nests all the time.
Yeah.
It's a journey. So, I mean, I'll probably date myself here a little bit, but, over the course of 30 years, from when I was a kid till now, 40 maybe, I guess, we've made a significant change in our environment that's for the better. We go walking. I remember one time I was in South Africa on a business trip, and I was driving on the freeway, and oh my God, I could barely breathe. Like, I mean, there was like black smoke, just pumping into the car.
Oh, wow.
And I just reflected on that, and I said, like, oh my goodness, I can't, these emissions laws that we're passing and driving this change, it's really good. It makes life a lot better.
What were you in South Africa for? That sounds fun.
Yeah, it was actually for work. There was a trade show in Cape Town, and then visiting some customers in Johannesburg. So
Nice.
Okay. Cool. Could you tell us some long-term implications of electrification in transportation?
Yeah, absolutely. So, you've also asked a lot of questions that I probably haven't answered completely.
That's
too.
okay.
The long-term impacts, right? So if you're thinking about the way that you use the vehicle, like, and this will be the case for every application of a reciprocating engine vehicle today, is you need to change the way that you're using the vehicle.
Okay.
And that will happen. One thing that I heard about a lot, it's very, people usually work like 8 hours, right?
Yep.
But then, like, you can think like an ultra-haul class truck, right? That thing probably is like $5 million, $10 million, right? You don't want that thing to turn off. You want to use it and use it and use it.
Yep.
So you don't want it. So you have like 3 drivers that are like working around the clock to make sure that truck never turns off, right? If you think about electric vehicles in the future, you need to charge them. They have to be charged.
Yep.
So where there's 3 drivers to every truck before, now you need to charge it maybe halfway through their shift, right? So one person needs 2 vehicles.
Okay.
So one can be charging, and while he's working with the other one, and then drops it off at lunchtime or whatever, and picks up the next one and takes it out fully charged.
Okay.
So you might, a lot of people are thinking that what's going to drive is a lot more need for vehicles. So
Right, because you'll need more.
You'll need more because you need to charge them. Like, you can't use them around the clock.
So just like switch out trailer that they're driving?
Yeah. Yeah, I mean, there's so many solutions, right? You could be like towing around battery packs with you, and then you could drop the battery, park off to charge, and use the same truck. I mean, there's so many solutions. And that's that's the part that I think is super exciting, is like how many problems there are and how many
Right.
different solutions there are, and like how would you ever know that where we're going to end up?
Yeah.
Yeah.
Yep.
You know, so
Interesting. I never thought of it that way, that we have to use them differently.
yeah, yep. And you know, like even like if you bought a car, you know, I think like a month ago there was like a really cold snap in
Oh, yeah.
Chicago. Everybody was like losing their minds because their electric vehicles, they couldn't charge them. They were all
Yeah.
running out of power on the freeway.
Oh, wow.
You know, and you think about that and you're like, you take a step back and you're like, well, why were all these problems? Like, people should know that, like, you know, you have to use a battery electric car differently than a reciprocating engine car. Like,
Yep.
it can be -40. I can go out and start my truck up and it's going to start most times, hopefully.
Hopefully. Fingers
know.
crossed.
But sometimes it doesn't. But what, you know, you deal with that. But the battery electric car, you need to make sure that like you really properly warm up the battery and everything beforehand so that it's working and you have a full charge. You know.
Yep.
So there is things like that we're going to have to learn a different way to use these tools.
Yep. It's a small price to pay for less emissions.
Yeah,
So.
absolutely. And for us, like, I mean, if it drives, you know, for Horton's business, if it drives more vehicles, that means more fans, more
Right.
electric motors, you know,
Yeah.
more vehicles, more opportunity for us to grow our business and get out there.
Okay.
So obviously Horton wants to invest into electrification so that way we have products for when the customers are ready for them.
Yep.
But we still need those core products. So how is Horton managing resources to make sure we give like equal attention to both?
That's a great question. And I've in kind of looking at the market, you know, you see some companies that are going like 100% in. Like they've basically taken all their engineering resources and they said, all these products here that we used to support, we're going to let them go, but they're going to kind of die off, and we're going to take all of our engineering resources and we're going to focus on electrification. That's not what Horton did. So we're looking at it as making sure that we have products to stay in the market and be with our customers, solving the problems, but also not betting the whole farm on the time frame. Right?
Yep.
So we're doing a really good job of managing that, right? So constraining some opportunities and making sure that we still have resources and finances to work on our core business, because, you know, and we know that, you know, the aftermarket story that we talked about before, like 2 of the
Yeah.
top 5 part numbers that we sell in the aftermarket were 20 years ago.
Yeah.
We know.
Yeah.
We know that those applications are going to be out there a long time, and that we need to keep those customers happy with our current performance to ever get a shot at the new stuff.
Yep.
So we're doing a good job, I think, of balancing that. And, you know, once a year, you know, or whenever there's resources available, our senior management looks at the projects that we can do and see which one we have resources for, and, you know, decides at that point where to, you know, direct those funds and people.
Okay.
So
Could you tell us kind of a little bit how testing works with our e-fans?
yeah. I mean, that's actually one thing that's like a lot different, because now we need all this electrical infrastructure to actually support our testing.
Yep.
And, you know, with mechanical, when there's a big fan running, you know that's dangerous. Just your brain just
Yep.
says, that's dangerous. We gotta stay away from it. Don't stick your hand in there. You know, your brain probably would never let you do it. You know?
Spinning things hurt.
Yeah, exactly. It's like flight or fright or whatever. You know, a lot of fright. But with electrical, you don't see the problems as easily, because it's really just like you put your hand here or there. You know, you could get zapped or
Yeah.
whatever, right? There could be a danger spot. So, you know, a lot of people when they're walking around, they put their hands in their pockets because, like, you know, as an engineer, I like to touch everything, right?
Yep,
But like,
right.
you gotta
Explore how it
be
works.
thoughtful. So that's one thing, like the aspects of how we manage it and in the training to people about what's dangerous and what's not dangerous. Which leads to different test cell requirements. So if you go out into the R&D building, you'll notice that there's a couple like shipping containers in there, like half cube shipping containers that were like kind of keeping all of everything that could go wrong in one little area to keep it a little bit more safe. So there's that. There's also the development that works that needs to happen with electronics and the testing that's different. Like we're used to doing like thermocycling and water tests and things like that, but like EMI, EMC testing, like how much radiation's coming out of there? How much can it take? You know, all of these things. These are things that we are developing. And so we're developing our knowledge and our testing resources to do that. So that's a couple examples there. The other part too is like in the past our clutches haven't needed to be cooled, you know, except for like with air cooling. But now we're getting into the point where we need to water cool the electronics, water cool the motors. So, you know, we have to manage with that in our test cell environment.
You got to have water lines and stuff.
Good thing we know how to do cooling.
Yeah, absolutely.
Is there like a market timeline you're working towards or any particular goals for when to like fully initiate, I guess, our electrification stuff?
Yeah, it's gonna take some time. We're learning a lot along the way. I will say that in my head this 2030 kind of timeline kind of is a big factor. We need to have the right parts to be available for that, so that drives a lot. The other part is Horton is a very customer focused company, so of course we need customers that are investing with us. So you know we need to meet their timelines for their product development of their vehicles. And so you know we asked a question about like how do you manage the trade-offs between where you're investing between you know clutches and fans and electrification. How do you do that? You know, a big part is customers. You know, if you have a customer that you've signed up for to support, you know, you kind of got to stop signing up with more customers. You know, you need to
focus on one at a time.
Focus at one at a time. Get the products out. So I'd say by in the next 2 to 3 years, we'll probably have 3 different nodes out into the market for electrification. Something less than 10 kilowatts, 3 kilowatt kind of range, up to 20 kilowatts, something like that. And like we've been talking the whole time, like if you've got the crystal ball to figure out what else is going to happen, let us know. But it's definitely going to change. Like our perception, I mean, it's so crazy how like daily the perception of the market changes. And our solutions and problems. It's just, that's definitely the hardest part about this. It's a generational investment that we need to make right now.
So when you're working with customers, I know like with our core products, we do like in-vehicle strain tests and stuff. Are you going to have to do that with like your e-fan too? And how does that work?
Yeah, absolutely. We got to work with customers to do all kinds of testing, in-vehicle strain testing. Another one is like if you think about the EMI, EMC noise problems, right? We need to do testing like that in the vehicle as well as here. We're going to do testing and certify to certain EMI, EMC levels internally, but then also the customers are going to take our products and take a whole bunch of other people's products that make a lot of noise and put them inside of the vehicles, and then they're going to do testing.
That system's going to make completely different noise.
Yeah, and it's not just audible noise; it's like the electrical noise. That's
and interferences.
I was talking to somebody one time how it affects like Bluetooth and stuff like that, and like radio signals and stuff like that, which is really interesting to me because I would have never thought of that.
Yeah, it absolutely does, and like stuff that you don't think about is like your brakes and stuff. Like a lot of times, like your tire pressure sensors and stuff like that is all wireless. So like if you're generating all this noise and then the computer can't see that anymore, then it doesn't know. So it's like, that's really important. But then also the audible noise is really a big thing for us and something that we're going to have to be really, really on top of, because it used to be that the diesel engine was the loudest thing. Not anymore. It's
the fan.
It's our fan that's the loudest now. So like everybody cares about our audible noise because they're like, man, that thing's noisy. And it's like, you know, like.
I feel like when people typically think about like even like electric cars, like when you back up, you have to have like a sensor, like a
You have to
noise
have an
sensor,
audible noise to back
because
it
they're
up.
so quiet.
Yeah.
So I feel like that's like a stereotype almost, where people think it's quiet, and then you get into like a medium duty truck, and you're like, why is this so loud?
Oh yeah, for sure it is. And even when you think about trucking, I think the trucks will probably have audible noise generated for a lot of the times too. But you think about it for, you know, construction too. I mean, when you're doing construction in like a neighborhood, like people care about noise, you know.
Yep.
And when it's zeroed in on your product as the noisy one, you got to really make sure that
You're the bad guy. You're the one who has to fix it.
Yeah. So we're going to see a lot of innovation in that area because of that. Because we're now the loudest part of the equation.
Yeah.
So,
Good thing Horton's got a lot of smart engineers.
Yeah.
Absolutely. Absolutely. It's right in our alley.
Yep. So if customers wanted to see our EFAM products, are there any trade shows that they're going to be at coming up?
Yeah, absolutely. We have a trade show coming up at ACT out in Las Vegas, and that's in May, and IVT in Cologne, Germany in June. So they can come check it out. I'll be at both the shows. So,
Nice.
You guys can talk to him yourself.
yeah, everyone's more than welcome to stop by and talk. Yeah, it's pretty fun, isn't it?
Yep.
Thanks everybody for watching today. Tune in for our next episode.
Thanks for watching.